In this lesson, we're going to look at properties of functions. So what is a function? It's a rule that assigns to each element from one set exactly one element from another set. Okay, each x corresponds to exactly one y. X and y are given specific names here, so when we talk about domain, we're looking at the set of all possible values of x in a function. And x is your independent variable, right? And range would refer to the set of all possible values of y in a function. Okay, let's look at a practical example. So you can pause the video and read the problem, which continues on the next page. An important function to investors around the world is the Dow Jones Industrial Average, a performance measure of the stock market. The figure below shows how this average varied over the year 2019. Label this function y equals f of t, where y is the Dow Jones Industrial Average and t is the time in days from the beginning of 2019. So here you can see the year, and then specific dates along the x-axis, and then you've got your closing average along the y-axis. Okay, and again, this function is labeled f of t. Okay, now, first question is it a linear function? We talked about linear functions in the last lesson in 1.2, and you can clearly see that it is not because it increases and it decreases over the year. It's non-linear, right? Now, could you use a linear function as a rough approximation? Yes, if you're in like a statistics class, you could, if you were looking at like a scatter plot, let's say, you could use a line to roughly approximate, but it is not linear since it doesn't have a constant rate of change and it is increasing and decreasing all over. So no, because it increases and decreases over the year. Should just be doing one or the other. It's nonlinear. Now, what would be the domain and the range of the function? If you remember, domain is x, range is y, right? Okay, so x here, though, is t, right? Because my function is f of t, so t is like in place of where the x would be, and t is time and days. So what we want to do is we want to look along the x-axis, and we want to look at, how many days? Well, I know that this is the beginning of 2019 all the way to the end, so I know that the domain would be from 0 to 365. And I can express that two ways. One way is what we call interval notation. So since I'm including 0 and I'm including 365, 0 would be January 1st, 365 would be December 31st. Since I'm including those, I would use brackets. Otherwise, I would put parentheses. Another way you can write the domain is, instead of putting the word or, I'll put a semicolon. You can also write it in what we call set notation, where we use the braces, so the squiggles, and we would say t such that, you put a vertical line, 0 is less than or equal to t, which is less than or equal to 365. So that tells me the domain includes every number from 0 to 365, or in this case, every day from January 1st to December 31st, right? So 0 is just the beginning of the day on January 1st, and 365 is the end of the day on December 31st. Now, the range is your y, okay? And y is just the closing average at any time. Well, I can see that the lowest closing average looks like it occurs here. And it appears that the highest closing average is down here. Now, it's really hard to tell exactly what it would be, but you can make some rough estimations. So it looks like the lowest is maybe 22,700. And then the highest, if I go here, which is where the peak is, that looks like it's about 28,600. You might have to take a ruler to go straight across to see. It's kind of hard to tell, but I did check it. So the range here would be, again, putting brackets because we're including these numbers. It goes anywhere from $22,700 to $28,600. Okay. You can also write it like this. So y such that y is between 22,700 and 28,600. Okay, so that's another way you can express it. Again, interval notation or set notation. Now, in the next example, it asks me, what is f of 16? Well, again, I know that 16 is t, it's time. So it's saying, like, on the 16th day, what would be the closing cost? So 16 is right in the middle of 0 and 32, so I just kind of gotta go up and figure out about what that would be, and it's about 24,200 maybe, so close to that. Again, it's an estimation. Sorry, 24,200. Okay, and here we want to solve the equation, so it's basically saying, when the closing cost was 25,000, what was the date? Okay, so now we know that according to this graph, well, here's 25,000. Okay, if I was to maybe draw a straight line, if I can, straight across from here. Okay, that's close to being a straight line. What dates did the closing cost reach 25,000? Well, I can see here that right around there. I can also see maybe here. So kind of late May and early June. So two places really. And maybe even right about there. Okay. So we can see here that at the end of January, so January around the 30th, 31st, maybe mid-February, and then late May, early June. Okay, so we may not know specific examples, but there's definitely not a unique solution because there's around 4 different places where the closing cost was, or the closing average was $25,000. Okay, so knowing about functions, right? Every x maps to exactly one y. I'd like you to pause the video and try to determine which of the following are functions and which are not. And then you can unpause it and we'll go over this briefly. Okay, and there are problems A through E. Okay, so hopefully you took time to try these problems. In letter A, we have something called a mapping, and A is not a function because, as you can see here, you've got an x value that goes to two different y values. It's not allowed to do that, right? Every x should go to exactly one y if it's a function. So A is not a function. B, if you were to look at the x squared key on a calculator, so if I was to graph x squared, right, I'll just go to Desmos and type in x squared, you get a parabola. And this is a function because it produces one y value for each x value. Okay, no matter what x you go to, you can go up and hit the graph and you'll get a y value, and every x goes to a different y. So that is a function. Letter C is just a table of values, right? They represent ordered pairs, which are just, a relation. And here you can see you've got two x's going to two different y values. Two x's going to the two different y values, two of the same x going to two different y values. So you guessed it, it's not a function. Is letter D a function? The set of ordered pairs with the first elements mothers and the second elements their children. So this would not be a function. And the reason it's not a function is because for a given mother, there could be several children, right? So if mother's x and children are y, the same x goes to different y values, which it's not allowed to do. Letter E is the set of ordered pairs with the first elements children and the second elements their birth mothers. So here this is a function because each child has only one birth mother. Okay. In this next example, we need to decide whether each equation or graph represents a function. We're going to assume that x represents the independent variable here, an assumption that we shall make throughout the book, and then give the domain and the range of any function. So if I was to take a look at y equals 11 minus 4x squared, okay, if you have a graphing calculator, you can easily graph it. And as you can see here, and that should be 4, not that it matters, but I want to write the right equation in. As you can see here, it's a concave down parabola. And this is a function because any given value of x produces exactly one y, just like the x squared problem originally. So this is a function. My domain, remember, would be all the possible x values. You can plug any x value you want in, and you're always going to get a different y value. So that tells me that the domain would have to be all real numbers. Okay, now my range is a different story. So as you can see here, the parabola extends forever, further and further down to negative infinity. But it comes to a peak. It stops at what value? It stops at where y equals 11. So that tells me that the range goes from negative infinity up to 11. So if I want to write my domain, so first of all, yes, this is a function. Okay, my domain in interval notation is all real numbers. Okay, so that's what that stands for, all real numbers. You can plug any x value in, you'll always get a different y value. But the range, remember, goes from negative infinity to 11. And infinities will always have parentheses around them. The 11, you need to ask yourself, should I put parentheses or brackets around it? So parentheses signify it's an open interval. Brackets signify closed. And when you go back and look at the graph, that very top point there is 11. Like the graph actually hits the 11 on the y-axis. So that tells me that it should be closed. It's including the 11. If I didn't want it to include it, I would put parentheses around it. So I'm going to put brackets around that. Okay, now you've got y squared equals x. So this time, if you think about it, you are plugging in a y value and squaring it and getting an x value. Okay, now I could take, let's say the number -2 for y and plug it in and square it and I get 4. But I can do the same thing with the positive version of 2 and square it and still get 4. So I just plugged in 2 different y values and I have the same x value. So right there, that tells me that this is not a function because each x should go to exactly 1 y, right? So therefore, we're not even going to find the domain and range because we don't have a function here. Okay, we can find the domain and range, but we're not going to. Okay, now you can practice. You've got 2 problems there. You can try those, see what you come up with. And then when you unpause the video, we'll talk about agreement on domains. So what do I mean when I say agreement on domains? Unless otherwise stated, we're going to always assume that the domain of all functions defined by an equation is the greatest subset of real numbers that are meaningful replacements for the independent variable. And remember, the independent variable is your x variable. So what this is saying is we're going to always assume that the domain is the set of all real numbers, except we need to exclude certain parts of that domain because sometimes values won't work for every function. Like if you had a function where you had an x in the denominator, okay? X cannot be any number in the real number system. If you'll remember, you can't have 0 in a denominator because it would make the function undefined. So we would need to exclude 0 from the domain. So we start with all real numbers, but then we little by little chop away the numbers that don't work. Another example could be if you have a square root. So the square root of x, you know that there are certain numbers that don't work with square roots, like negative numbers. You're not in the real number system anymore, you end up in the imaginary number system. So we would need to say that our domain, in that case, if it's the square root of x, would be x has to be greater than or equal to 0. Okay, what would happen if I was to take that square root and put it in the denominator? Well, now I can't even include 0 because you've got a square root and it's in the denominator. And we know the denominators can't equal 0. And you can take the square root of 0, but since the square root's in the denominator, you can't use 0. So in that instance, I would need to say the domain is x is greater than 0. Okay? So here we're going to find the domain and range for each function defined as follows. So we already kind of talked about this one, f of x equals x squared. Let's just graph it and take a look. So if you have a graphing calculator, you want to follow along here and type this in. If I type in x squared here, you can see that the parabola is concave up and the low point there, the minimum, is the point 0, 0. Now my domain is all real numbers because you can plug in any number for x and square it and you get a different y value. But your range, on the other hand, which is your set of possible y values, if you notice, there's no y values in the third or fourth quadrants below. So that means I need to restrict it and say that my range would be anything from 0 to positive infinity. Okay, so for my domain, I've got all real numbers, and in interval notation, we just write negative infinity to positive infinity and always use parentheses around infinities. And then your range would be from 0 to positive infinity. Now, the 0 will get a bracket around it because the low point actually is 0, 0, so it does hit 0, but the infinity will get a parenthesis around it. Is anyone familiar with the next example, which is y equals 6 minus x to the 1/2 power? Does anybody recognize what the 1/2 power is? So if you'll remember, anything with the 1/2 power is actually a square root. So really what that function is it's saying y equals the square root of 6 minus x. Okay, so let's draw a picture and see what it looks like here. We'll graph this. So we're going to type in the square root of 6 minus x. And as you can see, the graph starts right there at 6, 0, and then it shoots off to the left. So what that tells me is there's values for x that are not being used, right? Look at where the 8 is on the x-axis. There's no portion of the graph that touches that 8. Now, I also know that there's y values that aren't being used. So the graph is only in the top portion of the coordinate plane, right? It's only in quadrants 1 and 2. So that tells me that I also need to restrict my range as well. So the easiest way to do this is when you have a square root, to find the domain, you're just going to take the expression underneath the square root, which in this case it's 6 minus x. And you're going to just set that greater than or equal to 0. So you're basically saying, what does x have to be for it to always be 0 or higher? Because you can take the square root of 0 or any numbers higher. You just can't take the square root of anything less than 0. So now if I solve for x, right, I'm going to subtract 6 from both sides. You get negative x is greater than or equal to negative 6. And I need to either divide both sides by negative 1 or multiply both sides by negative 1 to isolate the x. And when you do that, remember that the inequality flips around. So you get x is less than or equal to positive 6. So what that is saying is that your domain has to be 6 or less. So it's going to be anything from negative infinity to positive 6. And I'm putting brackets around 6 because x can equal 6. If you plug in 6 here, you get 0 under the square root, and you can take the square root of 0. If you were to plug in any value less than 6, it'll be okay. Like plug in the number 5. 6 minus 5 is 1. You can take the square root of 1. It's when you plug in numbers greater than 6 that it's not going to be good. So like 7. If you were to plug in 7, you would get a negative 1 under the square root. And as you all remember, the square root of negative 1 is imaginary. It's the imaginary number I, right? And we're only dealing with the real number system. Now for your range, you can tell just by looking at the graph that the lowest y value that you'll get is 0, and then it continues on upwards. So your range would be from 0 to infinity. And the 0 would have brackets because it actually equals 0. And then the infinities always get parentheses. So there's your domain and range. Okay, you can practice the next 3 problems on your own. So determine whether or not they are, what the domain and range are for each of those functions. Okay, let's try evaluating functions again since we've done some work with these guys. So here we have a function g of x, negative x squared plus 4x minus 5. And we want to find g of x plus h. So what I need to do is take this x plus h, and I need to substitute it in everywhere there's an x, right? So easy. I'm just going to have g of x plus h equals negative, and then there's an x, so I'm going to substitute the x plus h squared plus 4 times x plus h minus 5. Okay, and now I just need to be really careful when I am distributing and expanding. So here you have the quantity x plus h squared, which remember is really this. Whatever you do, please don't square the x and square the h and call it a day. Okay, it's not the same thing. And then I'm going to just bring this down. And then what I'm going to do is I'm going to FOIL this. Okay, so first, outer, inner, last. I've got x times x, which is x squared. And then I've got my outer and inner terms, which both give me xh. And then I've got my last terms, which are h times h. We know that's h squared. Okay, I grouped that into brackets. Just you could use parentheses as well. Just another grouping symbol because I want to make sure I distribute that negative to that whole expression. And then I'm going to distribute through the 4, so you get 4x plus 4h, and then the negative 5 just kind of drops down. So in this next step, I'm going to distribute the negative through, and this guy right here, there's two xh's, so if I was to combine them, that would just give me 2xh. So what I'm left with is negative x squared minus 2xh minus h squared plus 4x plus 4h minus 5. And you want to double check, see if there's any terms you can combine, and there's no like terms. So we would just leave our answer like that. Okay, one more problem, and then I'm gonna have you all try the last one on your own. And before I forget, in this last problem, there's a typo. Actually, I fixed it in your notes, so never mind, that one's good. Okay, so let's look at B here. Find all values of x such that g of x equals negative 12. So this time I'm taking g of x and I'm replacing it with negative 12. So I would have negative 12 equals negative x squared plus 4x minus 5. Now I have a quadratic equation, which remember you want to make one side equal 0. So I need to move this negative 12 over here. So I'm going to add 12 to both sides. So you would get 0 equals negative x squared plus 4x, and then negative 5 plus 12 is positive 7. The first thing I want to try to do is factor this. Well, there's no numbers that if you multiply together, that'll give you 7 that will also add to 4. So I can't factor this. So if it's quadratic, you have other options. You can try completing the square. I wouldn't choose that method. That usually will turn into something nasty. Or you can use the quadratic formula, which always works. So let's use the quadratic formula, okay? If you'll remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, when I'm talking about a, b, and c, I'm talking about these values right here. A would be negative 1, b would be 4, and c would be 7. So I would have x equals negative b plus or minus the square root of 4 squared minus 4 times your a times your c, and then that whole expression over 2 times negative 1. And I end up with negative 4 plus or minus 4 squared is 16. Negative 4 times negative 1 is 4 times 7 is 28. So I basically have 16 plus 28, which gives me 44. So I have the square root of 44, and then all over negative 2. And then I'm going to kind of divide this up. I would have negative 4 over negative 2 plus or minus the square root of 44 over negative 2. And I know negative 4 divided by negative 2 is 2. So I have 2 plus or minus. Okay, so this square root of 44, if you'll remember, you can break the square root of 44 down into the square root of 4 times the square root of 11. And I know the square root of 4 is just 2. So really it's just 2 root 11 over negative 2. And I can reduce this, and I end up with 2 plus or minus. Now, 2 divided by negative 2 is negative 1, but you don't have to put the negative 1. You can just leave it as 1 square root of 11 because of that plus or minus symbol. The plus or minus is going to take care of the negative that would be produced by the 2 divided by negative 2. So your final answer is 2 plus or minus the square root of 11. So those are your two x values where that function g of x would equal negative 12. Now remember, that's two different answers. That's really 2 plus the square root of 11 and 2 minus the square root of 11. And if you were to type that in, 2 plus the square root of 11 gives you like 5.317, And then 2 minus the square root of 11 gives you something like negative 1.317. So those would be the two x values that would give you a y value of negative 12. Okay, and you can try the last one on your own, and that is the end of this video. If you have any questions, please feel free to reach out.